Hello, I'm Shan and you're watching Tec4Tric. So in this video, we're gonna see how to implement AND function using McCulloch Pitts Neuron. And we have to use binary data. Binary data means we have to use 1 and 0. If it was bipolar, then we have to use 1 and -1. So what is McCulloch Pitts Neuron? I hope you have watched the previous video. In the previous video, we have discussed about McCulloch Pitts Neuron in detail. So let's solve this problem. So first of all, we have to write the truth table for AND function. So here is the truth table for AND function. x1, x2 are the inputs and y is the output. So 1 1 1 0 0 1 and 0 0. So for 1 1 it is 1. So how to declare an AND function? Basically, for an AND function the output is high if all the inputs are high. So here we have two inputs, x1 and x2. See, both the inputs are high. That's why the output y is high. Okay, I hope this thing is clear to you. So now we have to assume two weights, w1 and w2. w1 is 1 and w2 is 1 also. w1 for x1 and w2 is for x2. So here is the graphical representation. There is x1 and x2 are the inputs, w1 and w2 are the weights associated to these inputs. Here the hidden layer activation function will be applied and then we'll get the output. So for input 1, 1, y input, we have to calculate y input first and then we have to pass this y input to an activation function. So y input is equal to x1 into w1 plus x2 into w2. So x1 is 1, so 1, w1 and w2 is always 1. So 1 into 1 plus x2 is 1, 1 and w2 is 1. So 1 into 1 plus 1 into 1 is equal to 2. So like this we have to calculate for the rest of the inputs. 1 and 0 it will be 1, 0 and 1 it will be 1, and for 0, 0 it will be 0. Now the question is when the neuron will fire. Question is when the neuron will fire. See, it is a AND function, so we can say that the neuron will fire if both the inputs are high. So basically here both the inputs are high, so the threshold value will be 2. The threshold value will be 2 or more than 2, but this was the conceptual theory. But how to calculate it mathematically? See, we can calculate the threshold value using this formula. Theta is greater than equal to n into w minus p. Theta is the threshold value. It should be greater than or equal to n. N is the number of inputs and w is the weights, positive weights, and p is the negative weights. So here n is equal to 2. N is equal to 2. Basically 2 is the number of inputs. W is equal to 1 positive weights and there is no negative weights, so p equal to 0. So we'll get theta is greater than equal to 2 into 1 minus 0, that is 2. So the output of neuron y will be y is the final. So this y is the final output. So it will be f of y input. F is the activation function. So how to define this activation function? It will be 1. The output will be 1 if y input is greater than equal to 2. 2 is the threshold value and it will be 0 if it is less than 2, but 2 is the fixed threshold value. So this is how we can implement AND function using McCulloch Pitts Neuron. In the next video we'll see how to implement AND NOT function using McCulloch Pitts Neuron. So that's it for this video. If you learned something new, please hit the like button, share it with your friends, and do not forget to subscribe this channel. Thanks for watching. See you in the next video.